Hello and welcome to video number 6 in the Weather Unlocked series. This episode is going to feature the different types of fronts. If you remember from video number 5, we discussed the different types of air masses, and those air masses are separated by fronts. We were going to talk about in detail cold fronts, warm fronts, occluded fronts, stationary fronts, and dry lines. You may have seen some of these boundaries and fronts before on TV weather maps. Here are some few facts about cold fronts. Cold fronts typically replace warmer air. However, it may not always be cold behind the cold front. For an example, let's say that it's near 100 degrees outside, and then a cold front comes through and it does knock the temperature down, but only in the 80s. It's not necessarily cold, so therefore it's relative. You may have to replace that cold with cool or cooler. What do those blue triangles mean that are on the cold front? Those point in the direction that the cold front is moving. If you're ahead of the front, that means that the cold front has not arrived yet. If you're behind the front, that means that it's already moved through. Remember that cold air is more dense than warm air. Therefore, a cold front is typically steep aloft, and it forces warm air to rise above it. And that leads to showers and thunderstorms that develop along the front. Cold fronts extend from areas of low pressure. Now let's talk about warm fronts. Warm fronts move through and they replace colder air. Warm fronts have red semicircles instead of triangles that point into the direction that the warm front's moving. Warm fronts typically have more of a broad slope versus the cold front. Therefore, you typically see more widespread cloud cover and widespread showers along and north of the front. So here's a typical warm front situation. You are located on the cool side of the front, maybe north of the front, and you have cool, cloudy conditions. Then later in the day, the warm front moves through and it becomes clear and quite a bit warmer. Here's a typical weather map that you might see with an area of low pressure, and you will notice that both cold fronts and warm fronts extend from that area of low pressure. So what happens whenever cold fronts move faster than warm fronts? Well, that cold front may actually catch up to the warm front and form an occlusion, therefore an occluded front. That's when the warm air is forced up and it forms that occlusion. In this case, this is designated by alternating triangles and semicircles, typically the color purple, and that indicates which way it's moving, as seen on the left. There are two types of occlusions. A cold occlusion, which is most common. This is when the cold, more dense air overtakes the warm front, and it also moves through cooler air mass ahead of the warm front. However, there are situations where you have a warm occlusion, where not as cold air catches up to the warm front. Therefore, it's forced upwards, and that colder air is able to continue on. Therefore, the most typical scenario is that cold occlusion. Now let's talk about stationary fronts. Stationary fronts really occur when the cold and warm air masses stop moving. They're not moving any particular direction, and therefore that front becomes stationary. And temperatures on each side of the front are typically about the same or fairly close to the same. You can get active weather along the stationary front, since those fronts do act as a source of lift for showers and thunderstorms. Now let's talk about the dry line. The dry line separates dry and moist air masses. These are very common in the plains and are usually oriented north to south. And they separate that moist air that's in the Gulf of Mexico, which comes in from the east, and that dry desert air from the west southwestern states. Typically, these dry lines move east during the afternoon. However, at night, they typically retreat or move back to the west. Now, dry air is more dense, and it's able to undercut the moist air, and it forces that up. Therefore, this typically leads to a combination or a clash of air masses where strong to severe thunderstorms develop along dry lines. And we typically see a lot of tornadic thunderstorms develop along these dry lines. So that wraps up this video on fronts. Stay tuned for more videos in the Weather Unlocked series.